Hi everyone, and welcome back to a new video about IB Math. In today's lesson, we will be studying how to find the inverse functions step by step for any function. We'll understand first the steps one by one, and after that we'll apply two good examples on that to find or to be confident about finding the inverse. And then we'll study the difference or the properties between functions and their inverses in terms of domain and the graph. So here, as you see, by the way, this is an important topic in the IB Math AA standard level and high level. So how do we find the inverse first? Here, as you see, if the function is written like this, f of x, then first we change the f of x to y. After that, we interchange x and y, like we replace x by y and y by x. Then after that, we make the y, or we make y the subject of the equation, and then we write it or replace it by the inverse. To clarify everything, we'll do this example here. And then after the examples, we'll explain the properties. So here, as you see, we need to find the inverse for this function here. We have a linear function, 3x plus 2. So as you see, by the way, first we replace f of x by y. So this f of x will be written as y equals 3x plus 2. Now after that, we'll swap x and y. So I will replace this y here by x. So x equals 3y instead of 3x. Then we will make now y the subject. So this y here, I will make it subject, or I will isolate it. First, I will move 2 to the left, or subtract 2, so I have x minus the 2. And then to eliminate the 3, I will divide by 3. So I will write here y first, equals, first x minus 2, as we said, we move the 2 or subtract it, then we divide by 3. This y that we got now is the inverse. So we just replace the y by the inverse notation, which is f of negative 1x equals x minus 2 divided by 3. So this is the inverse function. Now, keep in mind that f negative 1, or the negative 1 here, is a notation for the inverse. It's not a power of negative 1, or to do it, for example, 1 over f. No, that's completely different. So this is the inverse. Now, in this example, I will illustrate what we mean by this specifically here. Here, look, it says if a point AB is on the function f, then BA will be on the inverse, f negative 1. What does that mean? It means, of course, here, as you see, in one of the steps, we swapped x and y. That's why the point will swap as well between x and y, or a and b. To clarify it, see here. For example, in the original function, I will replace x by 1. For example, randomly 1. If you replace here x by 1, you will have 3 times 1, 3. 3 plus 2, 5. So I get 5. Now let's try on the other here, the inverse. Let's replace x by 5. If you replace x here by 5, you will have 5 minus 2, which is 3. 3 divided by 3, 1. As you see, the point is really inverted. It was 1, 5, and now it is 5, 1. This is what we mean by this. So what do we mean then by the domain here and the graph here? We'll illustrate that in the next example. But first, keep in mind, always for any function, the graph of any function f and its own inverse are reflections of each other across the line y equals x. What does that mean? For example, let's say that here we have the coordinate. Here we have the y-axis and the x-axis. Here we have the line y equals x, which is in the middle. It passes through the origin. For example, let's say randomly we have a graph like this, f of x, any function, could be any function. Then the inverse graph will be here like this. so that as you see, it's always reflection. They are reflection of each other across the line y equals x. Now, for example, let's say that the graph is not related to this function at all. Let's say that here we have the point 3, 1, for example. Then the symmetrical point to this will be 1, 3, because as we said, they will swap. Now, another good example here to illustrate the domain and range later. Here we have another function, which is, as you know, rational function or a fractional function. First, we need to state the domain and the range of this. Now, to remind you, by the way, this is what we call, again, rational function. I made a video about that appears top right of the screen. To graph this, by the way, the graph here has two asymptotes, a horizontal one and a vertical one. The vertical asymptote is the value of x that makes the denominator 0. If I make x minus 3 0, then x will be positive 3. So 1, 2, 3, the graph will be here. And for the horizontal asymptote, it's this. You divide the coefficient of x here by the coefficient of x down. 2 divided, by the way, here the coefficient is 1. So 2 divided by 1 is 2. The horizontal asymptote here will be at 2. And here, x will be 3. Here we have the x and the y-axis. Now, to graph it, we need to know the y-intercept. If you replace x here, every x by 0, then you will have only 1 over negative 3, which is negative third. This is the y-intercept, which is somewhere here, 0, negative third. Then the graph will be like this here, and the other part here. Now again, to know more about how I graphed this in a deeper way, you can see, as I said, the video that appears about rational functions. So now we'll answer the domain and the range. The domain is all the values of x. See here, you can replace any value of x you want, except one value, which is 3. It makes the denominator 0, so the function will be undefined. So basically, we exclude the vertical asymptote. Here, the domain will be all real numbers except, this means except 3. Now for the range, which is the corresponding values of y. In the same way, it's all real numbers, but this time for the y we exclude the horizontal asymptote, which is at 2, as you see. So all of the real numbers except 2. And really, to clarify, see here, we have a graph everywhere vertically, from the very bottom to the top, except at 2, it cuts. So we exclude 2 from the range. So now back to the inverse. Here we need to find the inverse. By the way, these are also important for finding the inverse and the domain range of that later. So here, to find the inverse here, as we said in the steps, first we'll replace f of x by y. So we'll have y equals 2x plus 1 divided by x minus 3. After that, we will interchange x and y. So I will say x equals 2y plus 1 divided by y minus 3. Then after that, we will make y the subject. But you see here we have y up and down. So we'll cross multiply here. When we cross multiply, we'll multiply this by the x, and the 2y plus 1 by the invisible 1 here under x. So if you multiply x by that, by the way, you can multiply immediately x by both of these, by y and 3. So x times y, and then x multiplied by 3 equals 2y plus 1. Now, every term that has y, move it left. Every term that doesn't have y, move it to the right. So we will have xy minus 2y equals, it becomes positive 3x plus 1. Since we need to make y the subject, I will factorize y. If you factorize y from this, you open a bracket now, you will have x minus 2 equals 3x plus 1. So now I will divide by x minus 2. So y equals 3x plus 1 divided by x minus 2. This is the inverse. I just need to replace y by the inverse notation, which is this. 3x plus 1 divided by x minus 2. So this is now the inverse that we need to find. By the way, you can jump immediately from here to here, like no need to write this. So this is now the inverse. What we need to find now, the domain and the range of this one as well. Here, by the way, if you see now, the domain will be all real numbers except for one value of x I cannot replace because it makes the denominator 0, and that will be 2 here. So except 2. For the range, again, like we did before in the example here above, for the range, we exclude the horizontal asymptote. Here, by the way, the range will be R, all real numbers are, except for the horizontal asymptote. To get the horizontal asymptote, you divide the coefficient of x here, 3, by the coefficient of x here, which is 1. So it will be R except 3, all real numbers except 3. Now see really here, look. For the original function here, the domain is all real numbers except 3. And now it is the domain here, look, I mean the range. Here the range is all real numbers except for 3. See the range of the original function, it's all real numbers except 2, which is the same as the domain here for the inverse, all real numbers except 2, which means also the domain and the range swap. And that's of course logical because we swapped x and y. This means, or this illustrates that the domain of the inverse is the same as the range of the original function f, and vice versa. The range of the inverse is the domain of f. As you see here, they swapped perfectly. For example, the range is all real numbers except 2, became here the domain, all real numbers except 2, and same for the other one. I hope that you have found this video helpful. Please hit the like button and consider subscribing. Thank you for watching.